So here I have a polynomial, and notice that it is the first three terms of sine, but I described it as a polynomial because we're not going to look at the infinite expansion of sine. We're just going to look at a polynomial of the first three terms of sine, and that is actually the first one I want to talk about, which is term. Term describes how many. Very simple. How many? How many things are there? How many, right? We know when we studied polynomials a long time in algebra class, this is a two-term polynomial, or this has two terms, right? Two terms. And then something like this has three terms. Very simple, right? You just count 1, 2, 3. So the terms of this polynomial is 1, 2, 3. So this is a three terms. So a question might say, write the first three terms of a Taylor series, and you just make sure you have three things at the end. I guess now the question is, why do people even confuse this in the first place? It seems quite obvious. Well, I would say that's because of the second part of it, the second technicality, which is order. Order, people a lot of times like to confuse order and term together because they seem like they're the same. Sometimes they could be the same, but they're not. Order is this idea, the partial sum of this thing. So we're talking about a polynomial in terms of a partial sum. So this partial sum is now p sub k, and I'll show you why I said k. It's from n equals 0 all the way to k of f, the nth derivative, and I'm going to use the Taylor series, or the Taylor part, so it's a instead of 0. And it also works with the Maclaurin series, this idea. So this partial sum, notice that it doesn't go into infinity. It stops at k. And since it stops at k, we say this is a Taylor polynomial of order n, order k at x equals a. I guess this x equals a just means this right here. But the key part is order k. Notice that we stopped at k, so it is order k. So the question is, what is the order of this? What is the order of this? It's not 3. It's actually 5. And let me show you why. So we have, let's actually do it. Find the n equals 0 to 5 of, let's use, since it's the Maclaurin series, we have to use 0. So like that. We write the first couple terms. I'm just going to speed through this. It's 0 plus, so that's the n equals 0 term. This is the n equals 1 term. It's x. And then the n equals 2 term is 0. The n equals 3 terms is minus 3, or minus x cubed divided by 3 factorial. The n equals 4 term is 0, and the n equals 5 terms is x to the 5th divided by 5 factorial. And see how I had to write 1, 2, 3, 4, 5, 6 terms to get to the 5th order, which is very interesting. Another way I would like to think about it is, how many derivatives did I take? Because 5 has to basically appear here. Since I took 5 derivatives, it is a 5th order. And that's actually why we describe it the way we do. Why is it called order? Because that's how many derivatives we take. If you remember when we took second derivatives, it's a second order. If we're talking about differential equations, you might hear this term called first order differential equations and second order differential equation. Order actually relates to how many derivatives we've taken. So second order differential equation means there's an equation with a second derivative. So order is closely related to derivative. And that's how I like to think about it. But if you want to find the Taylor polynomial of order k, you just basically want to find this, and this is what you would have to know. And this is like the go-to formula to find a Taylor polynomial for order k. So if you really want, it's basically the same thing, but the top is not infinity, it's k. So notice how order is different from term. This is up here, this is a 3-term polynomial, but it is also a 5th order Taylor polynomial. And then the last one is degree. This one's very straightforward. I don't think people mess this one up at all. but this is the highest exponent. The highest exponent there can possibly be, right? So if we're talking about polynomials, this is a second degree polynomial. This is a 10th degree polynomial. No matter how many terms I put, this is always going to be a 10th degree polynomial. So that's exactly what I'm talking about with Taylor polynomials. If I were to go up here, this is a 5th degree polynomial. So I'd say this is a degree of 5. Degree 5. So now we look at this, and I guess the first reaction I would get is, well, doesn't that mean order, since order is 5 and degree is 5, does that mean they're the same? Not really, because sometimes the 5th, when you plug in 5 here, you're actually going to maybe get something that is not x to the 5th. We might actually get something interesting, especially with Taylor parts. When we do Taylor series, it's going to be sometimes different, and we'll see exactly what I mean by sometimes different. Here's a quick example of what I mean by order and degree. So let me scroll down here. Let's say I'm going to use, let's use cosine this time. Since this is, I guess you can say this is the two things. It is the third order polynomial because the third term, or n equals 3 term, is actually 0, so technically it's not there, but it could be said to be a third order polynomial. But then this is a second degree polynomial as well. See how they're different. Order and degree can sometimes differ because of the lack of a n equals 3 term. So when I did the n equals 0 to 3 of the function, evaluated at 0, the nth derivative, divided by n factorial, x to the n. For cosine of x, I get 1 minus, well, I get 1 minus 0. So this is the n equals 0, the n equals 1, the n equals 2, and the n equals 3 term. So this is a technically a third order polynomial, but then that third order is gone. But it's still kind of there. It's 0, technically. But then this is a second degree Taylor polynomial. So there's a difference between order and degree, and there's also a difference between order and term, and you just have to remember that there's technicalities into their definitions. That's why I titled this Taylor series Technicalities, because they all seem like they can describe very similar things. Sometimes they do, like order and degree are usually the same, but sometimes they're not. And you want to be careful on what the question's asking. Are they asking for the first 5 terms of a function? The first 5 Taylor series terms of a function? Are they asking for the nth order of a Taylor series or nth order of a function using a Taylor polynomial? Or are they trying to find a Taylor polynomial with the degree of 7, for example? Which one are they asking for? And they all describe different things. Just know that order, you're going to just put in that top number to be exactly what that order is, always. So nth order, or 5th order, you're going to plug in 5 here, and then write the first 6 terms, technically, 6 terms. But sometimes that 6th term might be 0, so then it's a degree of whatever the highest is available. So there's a difference in all 3 of these terms.